Okay, part 2, here we go. As I said, most barcode monitors have an onboard photometer that tests the performance automatically. And this is what they look like. If you look at these barcode monitors, see this little piece of plastic right here? See this little piece of plastic right there? That is the onboard sensor. And every 30 seconds, it will calibrate these monitors. It will do it automatically, and it will run its own checks. And if everything's good, great. If it's not, it will automatically send an email to the PAX administrator and say, hey, my white balance is off, or there's too much ambient light in the room, and then you need to come and check them. Tests for modality display monitors. To carefully evaluate the comprehensive characteristics of digital display devices, there's a range of tests you need to perform, and they are geometric distortion, reflection, luminance response, display resolution, and display noise. So, geometric distortion. It arises from problems that cause the displayed image to be geometrically different from the original image, and this can affect the relative size and shape of image features. So, whatever the kidney looks like in the image, you want the kidney to look like on the screen. You want the patient's kidney, the image of the kidney that was taken with a machine, and the way the kidney is displayed on the monitor to all be the same. You don't want the kidney to look different on the monitor. So geometric distortion assessment can be done with TG18QC and TG18LPV-LPH test patterns. When you view the test pattern, all the lines in the test pattern should appear straight. And geometric distortion is most common in CRT display devices, and I don't think we have any more of those. So when you look for geometric distortion in the TG18QC pattern, you can see right here, that's the one I'm using. We want to make sure all these lines are nice and straight and parallel. And that's why it has all these different groupings of lines and things. You know, all the lines, both vertically and horizontally, should be nice and straight. Here are the two most common types of distortion. You're going to get pincushion distortion. This kind of looks like an old-fashioned pincushion, but you can see how the lines are not straight, they're curving. And this is barrel distortion because it looks kind of like the outside of a barrel. Again, the lines are not perfectly straight, so let me go back. Nice straight lines. Pincushion distortion, barrel distortion, lines with distortion. They're just not straight. Reflection. Ideally, a digital display has a luminance that's based on the light generated only by itself. However, in reality, ambient light is reflected by the digital display. This is why reading rooms are kept as dark as practical. Reflection is characterized in two ways, specular and diffuse. Specular reflection results in mirror-like images on the monitor. Diffuse reflection results in light randomly scattered across the screen. There's no test pattern to evaluate this. You simply turn off the monitor and evaluate any reflections in the monitor from within a 15-degree viewing angle. There are no such thing as viewing angles. You want to use viewing angles. Right. So here you can see the lights of the hallway in this monitor, right? So this is specular reflection, right? So I'm getting a mirror-like image on this monitor. That's specular, right? Now diffuse, you see here how 2/3 of the monitor have no light reflecting on it, and then in this last third, you've got light randomly scattered across the screen. Well, that would be diffuse reflection. Specular reflection, diffuse reflection. Okay, so luminance response. A digital image is stored as a matrix of pixel values. These pixel values are also grayscale values. These are converted into luminance values through a lookup table in the monitor software. The luminance response of a digital display device refers to how accurately it converts the pixel values into luminance values. TG18CT is the test pattern used to evaluate a monitor's luminance response. Now remember, all these different test patterns come all the way back from these guys. Remember, Task Group 18 came up with all these crazy tools to test these things. So there's a whole bunch of them. We're going to use TG18CT as the test pattern used to evaluate a monitor's luminance response. The pattern has 16 boxes with low contrast targets inside them. All 16 should be visible to some degree. And CT is just what they named it. It has nothing to do with CAT scan. So this is going to be really hard to see, right? So I've got a test pattern embedded inside a PowerPoint slide, which is being projected onto my crappy Lenovo monitor that is then being captured by some screen capture software. What you want to, if you can see, there's a yin-yang, a black and a white half moon joined together inside these boxes. Now if I ran this test pattern on a Barco monitor, I would easily be able to see all 16 circles, half moons, inside these squares. Because this is, an image I took off the internet, put in a PowerPoint, being shown on my crappy monitor, being screen captured to you. Hopefully you can at least see one, maybe two circles in there. But if we ran it on a monitor, you'd be able to see all 16. Display resolution. Display resolution is the number of distinct pixels in each dimension that can be displayed. It's usually quoted as width times height. Most Barco monitors are configured in a portrait mode, so the most common resolution setting is 1536 by 2048, which means the display is 1536 pixels wide by 2048 pixels tall. TG18CX pattern is used to evaluate display resolution. The CX pattern in the middle of the display and the corners of the display can be evaluated with a magnifying glass compared. Okay, so I'm not going to pull out a magnifying glass and try to count all the pixels in here, but if you look in the center square and you compare the corners, you should get about the same number of pixels, and it should look roughly the same. That's how you do display resolution. Last but not least is display noise. Display noise is any high-frequency fluctuations or patterns that interfere with the detection of the true signal. Noise is often a byproduct of statistical variations in the pixel value to luminance value calculations, right? So if the statistical variation, right, so the exposure value is 18.8 and the luminance value is 18, well, we've given up 0.8. There's a 0.8 variance there. And so it may not look exactly like the image, but no human eye can detect a 0.8 difference. So it's just how these statistical variations get involved in the equation. Noise is evaluated with the TG18AFC test pattern. In each quadrant, the two largest target sizes should be visible. We want to see big white dots. When I show you this, you're looking for big white dots. The monitor is considered to have passed the test if one quadrant fails. So there's 4 in a quadrant. 3, you're still good. So you be the judge. You tell me if you see a bunch of white dots. Okay, so this quadrant is good. Got plenty of white dots. This quadrant is awesome. Big white dots. This quadrant's okay. We got some white dots. This quadrant, maybe 1, 2, kind of down the middle here. So is it bad that there are no white dots in this quadrant? It's not great. That monitor's probably is slowly going bad. But hey, remember, you only need 3 good quadrants. So this monitor would pass. Thank you for watching.